Okay, so we have talked about rational and irrational numbers, and now we're going to learn another type of number, which is called complex numbers. So what you'll notice is students will know there's a complex number such as I, and so we define I to be the square root of a negative number. Because if you try to type that in on a calculator, we've been taught we can't take square roots of negative numbers. So in physics and other sciences, there was a need to define imaginary numbers. So a complex number is in the form a plus bi, where a is the real part and b is the imaginary part. All right, so I'll skip down here, right here. So a is real and b is imaginary, and it's really easy to identify because it has the I with it. Okay, so you can treat it kind of like a variable, but it's not really a variable. So what is an imaginary number? It is a number whose square is less than 0. I is defined to be the square root of -1 by definition. So other imaginary numbers, we just use I. So if we ignore the negative, if I had the square root of 16, I would get 4. And so we can think of this as -1 times the square root of 16. We've seen that before. So the square root of 16 is 4. The square root of -1 is I, so 4i. Same thing with 8. I know there's a negative there, so we're going to bring out the I, and then we just break that 8 down like we did before. So 4 times 2, we're looking for doubles. So here's a double, here's a single, so it would be 2i root 2. Okay, so breaking down radicals, adding radicals are all the same. When we add or subtract, we're going to add the coefficients of the real part, and then you also add the coefficients of the imaginary part. All right, so if you had 5i plus 3i, you would get 8i. All right, now there are certain powers that we can do, and for the most part we're going to stick to 2 or less, but I just want you to notice the pattern. So anything to the 0 is still equal to 1. That rule doesn't change. I to the first is -1. I squared, well, what if I had I squared is the same as I times I? That's -1. That's the square root of -1. And remember, when you had a double, we could take those out, and it just becomes the number inside. I cubed is the same as I squared times I to the first. So if that is I squared times I to the first would be -1i. What if I had I to the fourth? Well, I to the fourth is the same as I squared times I squared. I squared, we said, is -1 times -1. -1 times -1 is +1. And then we're going to keep going. I to the fifth, well, that's times I, so 1i. And notice that was also I. I to the sixth, same thing, add another I there. So I times I is I squared, which is -1. -1 times 1. And so are you starting to see there is a pattern? So every 4, we're just going to get the same answer. So yes, every power of 4. So if we had I to the 16th, well, I'm going to take out the 4s. So if we divide that by 4, it goes in 16 times, and so we're left with 1. So I to the first is our leftover. Same thing, I to the 26th, if I divide by 4, it goes in 24 times, so we're left with 2 of them. So I squared, which is the same as -1. Okay, so we can do huge powers just by knowing that pattern. But we're going to spend most of our time just doing operations. So the real part and the imaginary part we've talked about. If a equals 0, then that means that this would go away. So we would have 0 plus, let's just say 4i. And so that's why they call it a pure imaginary number, because there's no real part. Okay, so if we're given 2 plus 5i, the real part is the 2. The imaginary part is the 5i. And if you want, you can put a plus there because the sign does go with that. So our operations, we said to add the real parts and add the imaginary parts, the coefficients. So 6 plus 4, 5 plus negative 8, and I just like to put one sign between them. Okay. Example 2, we have two distributions that we need to do separately. So 4 times 3, 4 times negative 7, negative 3 times 8, negative 3 times negative 2i, and then we would add the real parts and add the imaginary parts. Okay, it's not wrong if you put the imaginary part first. We just typically don't in math. So now we're going to FOIL. So remember, that means 5 times 3, 5 times negative 9i, 2i times 3, and I like to put the sign with it. And then this is the hardest one. 2 times negative 9, and then it's still I times I. So you will have to remember that I squared, by substitution, is negative 1. So negative 18 times negative 1 is positive 18. Okay? So we're going to add the real parts. 15 plus 18. And then this is a negative 45i plus 6i. Okay? All right, now we're going to break down some radicals. So I like to think of this as negative 1 times 25, and then break down the 25. And remember, you're looking for double since it's a square root. So this is I, and these are a double, so I would get 5i, and there's no singles left, so that's my answer. Square root, so we're looking for a double, so negative 1 times 216. 216 is not something I deal with, so let's see. It goes in 2 times 108. I'll bring the 2 down, so that's 2 times 54. 2, 2, 9 times 6. And I like to just keep bringing them down. If you want, you could have taken them out. I just chose not to. So I know this is I. I've got a 2 and a 3, and then these are single. So 2 times 3 come out. Remember, you multiply. And then 3 times 2 stays in, and you multiply those back together. All right, the last one. You don't want to multiply negative times negative, but I can think of this as all one big root, so otherwise you won't get the right answer. Now, right now, if you recognize that we have a double, we can take that out. Break down 24. Break down 20. Remember, you can look for doubles anywhere. So here's a 2. Here's a 2. Single, single, single. So a 2 times 2, I'll just write it out here. And then we have a 3, a 2, and a 5. So negative 4 root 30. All right, well, good luck with your complex numbers. Let me know how you do.